Si c'est à l'heure, bon, très bien. Ok.
Alors, bonjour tout le monde. Je vous demanderai de prendre place. Nous allons débuter, il est 1h02. Alors, effectivement, nous commençons à l'heure. So, hello everyone. Welcome to this webinar with Augustin Chaintreau. My name is Sarah Fortin. I'm the Knowledge Transfer Coordinator for the Canadian Research Data Center Network. I'd like to say that the activity today is organized in collaboration with the Quebec Inter-University Centre for Social Statistics and the Department of Demography at the University of Montreal, as well as McGill Center on Population Dynamics. So as you can imagine, we have participants attending in person in the office of the KICS in Montreal, as well as through the internet. My voice is coming through the internet. I'm myself attending through the webinar. So before I introduce our speaker for today, I would like to take just a brief moment to introduce the network for those of you who may not be familiar with this research infrastructure. So the CRDCN is a partnership between Canadian universities and Statistics Canada. It is truly a pan-Canadian network, as we have 27 research data centers currently located across the country and soon to be 30. And this includes, of course, the KICS in Quebec, which has 5 facilities across the province at the University of Montreal, McGill University, UQAM, Laval University, as well as University of Sherbrooke. Research data centers are secure computer labs, generally located on a university campus. RDCs allow researchers with an approved project to use the wealth of data gathered by Statistics Canada, including household and longitudinal surveys, census data, and an increasing number of administrative data sets. Last year, more than 1,500 researchers from various disciplines have accessed an RDC, and about a third of them were graduate students. The research carried through the network is very diverse and have helped to better understand social and economic as well as health, affecting the whole society, as well as factors affecting individual life course and well-being. This includes issues such as population aging, economic integration of immigrants, social economic determinants of health, income inequality, and child development, among other topics. To know more about us, I invite you to visit our website, where, among other things, you can search the online bibliography to find the most recent publications of interest to you, or you can also browse the data search engine to see what data sets are currently available through the network to carry your own research with these data. So, without further ado, let me introduce our speaker for today. Professor Augustin Chaintreau is Assistant Professor of Computer Science at the Data Science Institute at Columbia University, and is also Director of the Mobile Social Lab. The goal of his research is to reconcile the benefits of leveraging personal data and social networks with a commitment to fairness and privacy. His latest research result addressed transparency in personalization, the role of human mobility in privacy across several domains, the efficiency of crowdsourced content curation, the fairness of incentives to share personal data. Before we start, just a bit of housekeeping. Augustin will speak for about 40 minutes, and then we will have a Q&A period. Until then, for those of you who are attending through the internet, your microphones will be muted. Augustin's presentation will be in English, but if you wish, of course, you're most welcome to ask questions in French when it's in advance. And for those of you attending through the internet, if you wish to ask a question, you can either write it out using the question tab on your right-hand side, and I will read it for you, or you can raise your hand, click on the little hand there, and I will unmute your mic so you can ask yourself out loud. So, Augustin, without further ado, thank you for being with us today, and the mic is now over to you.
Thank you, Sarah. It's great to know a little bit about the context of where I'm speaking and how it goes. I'm going to talk for 40 minutes, and we have time for Q&A. At the same time, if anyone, especially in this room, has questions, and I can repeat the questions perhaps with my microphone, or they can use that, especially clarifying questions. The point is for everyone to understand what I'm doing. So any point that it could be interactive, don't hesitate. I'm always happy to take a minute and clarify whatever it is, and follow up with you offline if you need. It's a great pleasure to be in Montreal, and thank you so much for accommodating my possible dates. My wife and I, we have a little house north of Montreal from our family that we visit sometime, and we thought around November 8th would be a pretty good time to be out of the US in the woods somewhere, so in case anything happened, we're already protected from the craziness, and so we decided to sort of make this trip. And at that time there was also a fantastic invitation to come here, and it's really, really wonderful to be here. I'm going to talk to you today about actually a follow-up conversation we have from people in the University of Montreal on how we can use social media for demographic research. And I would like to do a couple of things, which would be, oh, actually I see myself, which is maybe a little annoying for people here. Perhaps I can cut this. So I'd like to start maybe, about 10 minutes to say how I came to care about demographics in big data. My background is I'm a computer scientist. I worked, starting in applied math on an applied probability to understand things like the internet and build new protocols. And there's no like a direct connection, obviously, to the understanding demographic of population. And also this sort of, very particular relationship between computer science and social science in this domain really evolved very fast in the last few years. So I just want to sort of share a little bit the lesson learned from here. For people who went to my talk yesterday, you'll see a little bit of that as well. And I'll be happy to talk more about this, related to whatever, your PhD topics, your next project, anything. This is a sort of a broader discussion. And then I'd like to bring a few technical bits to you that I hope will empower you in using social media with a sort of, bias towards showing you some of the risks, so things you probably should be careful about while handling this data. You probably know many of those, but there are new risks, so it's important that you're aware of that. And also the opportunities we have today with our current tool. And I'll go over probably this particular way, which is to first show you some results, things that are a little interesting, outcomes, and then maybe discuss a little bit the methods and how, what are the steps that are important. I try to do that in my class, because if you just discuss the method first, nobody, really here to wants to learn about method first. But if you see what you get with the method first, then maybe you are a little bit more interested to learn about it. And then, we can conclude and follow up with questions. How does it? Maybe it's so. Do we get?
Oh, interesting. You just click anywhere on the PowerPoint. It's going to refocus with the mouse.
Oh, I got it. Because yes, because I was just going there. Okay, so for a while I worked on using social network for building new protocols, things like peer-to-peer systems that will use mobile phones to discuss with together. And for a while, my sort of idea was that, okay, in computer science, we have new application, we have new data, we have many things we can bring to social science. So I was more or less saying, I'm doing my job, and whenever I have something that is useful, I should probably tell social scientists about it, they can use it. And in the last few years, this evolved dramatically for something where I actually need actively to discuss with them about research problem because we need social science expertise in the way we build tools and protocols. And I'm going to give you an example that actually is from this morning. If you go to the ProPublica webpage, which is a website I actually highly recommend you read regularly, they have today a reaction to one of their very recent postings on how Facebook is today using ethnicity as a way to include or exclude particular users from ad campaign. And the last development was that this morning, 4 members of the US Congress actually wrote a letter to Facebook to say that they should actually stop, that there is, it's actually against the Fair Housing Discrimination Act that was proposed in the US, in a few decades. So this particular was from an example that was brought a few days ago, actually, that shows that if this is actually the little console you have if you are an advertiser who want to use ads on Facebook, and you have these two things where you can include and exclude, and most things, that this journalist looked, they were able to basically target people who are looking to buy a house, are first-time buyer of a house, or just doing house hunting, and just include them. And if they wanted, they could sort of exclude African American, Asian American, and Hispanics from that, which is essentially a way to say, there are these populations that I don't want my product to be seen by them, like my product for housing and things like that. That was clearly sort of, an outrage. And one of the most interesting, fascinating part of this piece of journalism that I recommend you read is that the spokesman from Facebook said, actually, oh, you're wrong. We are actually not doing any racial discrimination, because what we are using is this thing called ethnic affinity, which is just seeing what type of content you like, what's your behavior on Facebook. And if I, read that, it's not the same as race, which Facebook do not ask you member. Facebook assign member in an ethnic affinity based on page and posts that have liked or engaged with on Facebook. And when the journalist when we ask why ethnic affinity was included in the demographics category of the ad, then, the spokesman say, actually, we're going to change that very soon. So that's a sort of, an immediate reverse of what they have just been saying. So we are seeing this coming over and over. And this is just, an example from this morning, but there are actually even 3 examples from this month that relates to that. You have today essentially personalization at very large scale in tons of the commercial and public services we're using. And it's not an exaggeration to say that it runs a whole spectrum of bias and discrimination that we came to know and see in our society. If you look at how the sharing economy, which basically create a profile for every user who need a ride or an accommodation, like in service like Uber and Airbnb, that has been shown to exacerbate discrimination on a very large scale. There was an article, I think it was, on Monday, about the Washington Post about how Uber driver will cancel your ride twice more if you are Afro-American based on the first name you indicate in your profile. You will have, similar situation in Facebook. That was actually the article that was a few days ago. You might wonder, well, those were journalists playing a little bit with the system. Are really people using this to do, a large-scale demographic, racial difference on ads? Well, there was an example at the beginning of the year that was a particular movie, Straight Outta Compton, which is sort of a movie about the hip-hop culture and how it came to be. That movie had 2 different trailers that were shown differently to people who were, according to Facebook, in the Afro-American ethnic affinity and other people. And the idea for this trailer was to say, well, for people who have absolutely no exposure to hip-hop culture, maybe they need a trailer where they need a little bit more background, what it is about. For others, you can go straight to the, the sort of key selling point of the movie and have a slightly different bias. That may seem like a benign example because, it's about movie and advertising it. It's maybe not something that, is as pressing as housing discrimination and others, but it starts to create the question of what is actually ethical and what is actually doable in these networks. And as computer scientists, we are really right now struggling to answer that question. We really need to work with you guys. And so, in the last few days, I really went to attend workshops where I can learn from expertise on, what it is to understand underrepresentation and effects of those in our society in order to better design our system. And I think many of the companies and the products that are here continue. If you want more example, I can continue on October 11. Again, the Washington Post shows that Facebook, Twitter, Instagram were actually aggregated in this firm called Geophidia, which is essentially bringing a sort of tool for law enforcement officials to monitor various parts of the US country, especially places with racial protest. And that tool essentially is having as one of the outcome of this use that some particular minority are targeted way more by the monitoring and the police enforcement in this area. Again, what part of that is acceptable, what part is unacceptable is up, I'm a computer scientist, I cannot define that, but I definitely want to build tools to empower everyone to answer that question. And so I'm going to come to technical bit of my research in a minute, but I just want to say why do I work on that? My goal is to reconcile the disparate impact we see in big data that is not going to go away because big data is about making differences between individuals. But how can we reconcile that with important societal values we have that we also may want to rediscuss and redefine? I'm doing that to multiple ways. I have multiple projects on how to build an infrastructure to make the personalization transparent. If you want to learn about that, I'm happy to answer a question later. This talk is going to be way more on the second theme that I'm doing, where I look at data about users that are fragmented in different domains and seeing what are the risks and also opportunities to understand better disparate impacts with this data set together. and we'll talk a lot about that today. And there's another theme that is important on how social sharing basically reinforces inequalities in access to services and information. And I can go on that offline if you're interested. We have various requirements. Everything we build should be reusable tool. We don't want to build a tool that is only solving one particular case. We want building blocks that anyone can reuse, just like computer scientists like to sort of reuse bits and pieces from various codes. Everything we do needs to be incrementally deployable. I'm not talking about building a new Facebook for the future that is private, because that's a very interesting problem to do, but I'm not going to, we're not going to deploy that tomorrow. We need to actually solve the problem we have today. And we need to validate everything we do. Most of the study on social media, you will see if you look at the conferences where my work is published, like ICWSM, many of those papers come from data that are under proprietary companies where you can't really access or even reproduce the study that is produced. So there's a big question about how can we do that, and one of the stand we have in our lab is to use only reproducible data sets. So everything that I'm showing you today, with one exception that I will point out, are all made from collection of information that are publicly accessible to anyone, and anyone who would like to reproduce our results, prove us wrong, or prove that there is something better can redo. And so that's sort of the general research I'm promoting, and now I'm going to sort of more zoom in on a few examples where hopefully the lesson learned would be relevant for your research project. The first one is about a risk, and I'm going to identify a particular risk that we have to do. But before that, I'd like to see why we need particular new tools for understanding mobile social media. So mobile social media, there's a little bit of a disconnect right now between the research and the reality. The research is like this. You will have a proprietary company, I don't know, your Foursquare, for instance. So you have a big database where every user has an ID. You have a list of latitude and longitude and time where they've been. So you can sort of, track very well their behaviors. And maybe you have some information about them through demography. Maybe you know that they are female or male, or maybe other things about them. And that's sort of your big data set. And of course, you're very careful, because users are very sensitive to that your data set is not going to be shared with anyone and is sort of protected from others. Or if you're a university, you don't really want to increase revenue, but you want to increase knowledge, you're going to actually follow exactly the same architecture. You're going to make a study, you're going to maybe through survey or through other way, build a big database with every user assigned with some particular information. And those are isolated silos, and in a way, it is isolated by design, because everyone is scared about the possible contamination from information here to one here. If this indicates, for instance, sexual orientation of the individuals, you don't want an individual to be recognized in another data set and some of their information be released to another third party. The problem is that's very nice. We have lots of research papers on how to do that properly, how to avoid that privacy leaks and things like that. The problem is it's completely away, at odds from what people do today. What people do typically is having their information scattered in multiple third parties that are on their phone. I'm putting a few examples here. You might use Instagram. Whenever you use Instagram, most of the pictures you send are geotagged by default, unless you decide to opt out. If you use Flickr, you have similar things. In Twitter, there's actually about 15% of the tweets that are geolocated by a choice of the user to indicate their position where they tweet, which could be used for personalization or recommendation and others. That's sort of the part we know about and where we publish papers in conferences about this. That's also all the other parts that we rarely discuss, but that create a lot of these records. For instance, every time you use your credit card, there's a transaction that logs somewhere that you made a particular sale and you have to use your credit card in person, or if it's online, it's actually indicated as an online purchase. So the offline indicates where you are, the time and the location of the vendor. Every time you make a phone call or SMS, there's one part of a database in one of your service providers that needs to record for billing purposes where you were and which cell tower you used, especially if you go across networks. And then there's all the other ones, any other app I didn't list on that slide. And if you're like, well, how many could there be? Well, there was a study showing that on your phone, about 3/4 to 2/3 of the apps you're using ask for location. And they will request your location. And if you, turn down, the ability to get location, the ad will somewhat, stop functioning or ask you again to turn it on, etc. There are cases where, you want to use Uber or Google Maps where it makes complete sense that the app knows your location in order to get service. But there are even apps like the Lamp Torch on your phone or the Angry Bird game. All of them collect your location. That's why 2/3 of them. The main reason for that, behind probably just a sort of gluttony of having more information about their user, is that you could use that to personalize the ads you show in the app. And ad networks are very, resistant to showing ads to people that are not localized because they have no idea where they are. It's a little hard to play an ad that is relevant or that an advertiser would like to pay. So all ads by design, if they have advertisement in there as part of their screen, they would require location just to be sustainable. And that's why I'm just putting here this big question mark, which are all other third parties, including some that don't have a name like Instagram or Twitter, which could be put to shame in newspaper and things like that. People we never heard about, and many of those third-party apps actually access large number of locations. And as a user, we are basically a part of this gigantic ecosystem where we maintain information between these apps. A priori, these databases do not discuss too much with each other, except in the case of advertising. I can go in more detail with that. But they have one thing in common, is that they all indicate bits of geographical location. And geographical location is an absolute. Like if you have a GPS in your Instagram geotag pictures and you make a transaction, this is going to be the same actual location on the planet. You can't be in two places at the same time. Similarly, there are, you can look at the click stream through your browser, and that's also a sort of universal thing that happens in many situations. So if you click on an ad, for instance, you may open a browser, and that will be sort of a click that whenever domain you come from, it will be reconnected to the same resource. So that poses a lot of new questions. And while we have research that typically are like this paper or this paper or this paper showing that in a particular data set there are risks for users to be uniquely identified and there are ways to remove them and avoid leakage, the problem is that we need to address new problems that comes when the data is fragmented between domains. Questions like, can two profiles I maintain on two different systems be linked? If my OkCupid profile contains, various information about my my personal life and my sexual orientation, I don't necessarily want that to be immediately linked to my Twitter blog, microblog profile that I'm broadcasting to the world. This is the kind of thing users don't want, but that actually could be technically done, or at least we should study. The problem is we don't really have data set for that, because cross data set with the same user is very hard to maintain. So I'm going to discuss how we came to this to look at that. Another question that I'm going to go in the second part of the talk is, can my behavior in one system be used to discriminate me in another? Typically, if I share my location with one service, can this service be using that information, maybe the one I'm giving to Uber or Google Map, without anything else to infer another feature like my demography? And we saw in Facebook that Facebook is not asking users for their race, explicitly, not like the census or anything like that, but through other behavior that people are doing on their website, they can essentially create an information that correlates with it that is extremely accurate. So you might seem that on Facebook, well, Facebook has a lot of behavioral data, lots of things about your tastes, the various type of music and friends, and so maybe this is a lot of correlation with your race. This is going to be hard to remove, and probably that's true. What happens if you have just a little bit of location, a few check-ins? And the danger here is that, okay, Facebook has a lot of information, but it's Facebook in a way. It's a big, player. All these third party, like this little app that have just, 5 zip code I used, there are many, many more of them. And it's going to be much harder to track them and check that, they are not doing anything wrong with it. So that's, sort of the big question we have there. So we need to know how little information do you need to make such a, for instance, the same thing as what Facebook is doing. So I'm going to discuss, a little bit the first question and the second question, and then discuss a little bit about the method to address those that I hope would be relevant for your research. So the first problem we look at was this problem of reconciling identity in different data sets. So we won't go into any technical detail today, but I just want to sort of, that you have an overview of what type of result can be obtained. So we have 2 persons, for instance, represented here. This person follows this trajectory. This other person follows this trajectory. This is a sort of a space that is, one-dimensional, and this is time. And as happens in many cellular networks or any systems, you can have, cell spaces that are, whenever you're in a location around here, you're assigned to cell 1. Maybe it's the zip code, or maybe the cell tower, or maybe something. So it's not like I have a real number. I have more like a discrete set of locations. And every user is actually using 2 different services and creating mobility traces in 2 different services, not simultaneously. maybe, you know, at that time that user started the trajectory. At that time, that user maybe create a transaction record with a credit card, and then later made an SMS, and then later again bought something with a credit card, then 3 calls, and then another transaction, and then a call. So from the point of view of someone studying this, if you are these 2 services, you have somewhere on a database of the credit card company those 3 transactions, anonymized. You know, there's no real name to that user in this database that is associated with here. And here we have a call, the various call made by this user that are also sort of separate. The question is, if I have a pair of credit card and call for a large population of users, let's say every resident of New York, can I recognize just based on, you know, the overlapping mobility between the 2 trajectory in different domains that this is the same person? So can I, you know, if you take a salad bowl, you put credit card, and another salad bowl, you put cell phones, can you recognize and pick, you know, which credit card belongs to which cell phone? That's the sort of question we're answering here. So if you discretize the time, you could recognize that as being, you know, I have a green user, which is one of the green record for location, and this user has, if I look at 4 time bins, so I divide the time into, you know, 4 different periods. This user has, you know, in this location at that period, in this location at that period, in this location at that period, and nothing in this period. And every user is sort of, you know, a matrix like this. And I just want to see, you know, how this discrete information can be used to link people. And what we found was actually using an inference using the properties of Poisson process, which is sort of a fundamental probabilistic tool that is looking at how events happen somewhat by chance in time. Using you know, various properties of how Poisson processes are coupled, we were able to build an algorithm that basically creates a score between any pairs of records, any pair of, you know, a transaction of credit card or and a transaction, a number of phone calls from a telephone. And for each of these pairs, we have a score. If you try to find the matching between 2 populations that has the highest score, we prove that using this particular formula, this would actually give you the correct identity reconciliation with high probability. And moreover, we try to test that with reality and real data. So this is where this part is actually not reproducible. We had to work with a particular startup that has access from credit card records and phone call for the same set of customers in one country, you know, through a sort of agreement with both of them. They could associate users by email. So we have actual ground truth of who is whom. And we ignore the email. We just try to look at from the mobility, can we guess who is who? And that's where, you know, our precision and recall would play. So that means that, you know, using our algorithm, we were able to reconcile 20% of the user. So that means that 1 user out of 5 in this country would be correctly associated with their self in the other domain. And that happened with a precision about 40%. So we can be wrong, you know, for 4 users out of 10. So we're going to make an association for everyone. We're going to, you know, be wrong 40% of the time, but there is actually 20% of the population where we are right. That's sort of, you know, the level of noise that we are dealing with here. And the reason why, you know, these are not very accurate results is because this is a country where transactions were extremely rare. You know, the credit card were used something like 3 times a week. So when you had, you know, only 12 points during a month to connect and distinguish between 10,000 of users, it's really, really hard to do this task. So this is somewhat, you know, a remarkable result to attain even such level of accuracy. Now, if you don't use this sort of very hard data set that we looked, if you look at how people share information on Instagram and Twitter, or between Foursquare and Instagram, places where we could actually crawl public information and link profiles that use the same real name or email address or connected them through the network, we were able to show that using location only, you could get to 100% precision for at least, you know, 70% of the account in this case. And here you would have a sort of 80% precision for about half of the data. So it's possible to use that. You know, whenever you have mobile data sets, you could use various algorithms. I mean, I would argue that you should use ours, that is shown in red. But there are other algorithms that are, you know, performing also not too bad, you know. And those algorithms will help you reconciling who is whom with a level of noise, definitely. But in some cases, especially when the data is plenty, like in the Instagram, Twitter, then the level of noise starts to get, you know, low and low, and you can basically do a much better reconciliation. So it's important because whenever you use mobility dataset and you access it from two populations, well, there's really no guarantee that a user will not be recognized. In each of these cases, including the very hard one, there is a very non-significant fraction of the users that were recognized between these two datasets. So from the point of view of privacy, it's a little bit of a warning that we should be careful with anonymized mobility traces. It's actually doable, even when the datasets have not been collected at the same time, show various behavior. You know, you don't make call exactly where you buy things. I mean, it's slightly different. But even then, you are able to reconnect users together. That's all for a first turn of importance about how to use mobile social media properly. The second thing that is going to be a little bit of an optimistic message is how can we use them to enhance our knowledge of mobility. How many time do I have left? Just to check. Great, excellent. 10, 15, great. Okay, so I'm going to go back to what, this thing where I was presenting how we use mobility datasets. So my vision, as opposed to this silo, different dataset that are, everyone collect and use separately, what I would like is basically that we embrace what is the current situation of the web, where users are basically willing to share a lot of public information on various services, in which they share bits like their pictures and their location at the same time, maybe on different services like Instagram and Twitter, Flickr in this case. What we build in our system is essentially the first piece of an infrastructure that will allow someone to crawl the public web. These are public information, so user in a way we're releasing that information, on purpose to the web to sort of share their behaviors. And through this crawl, what we did is we essentially extracted features from the pictures, as well as the metadata that are contained in the profile. And when you do that, you could actually interpret the profile of a user online, not just as, okay, there is this user with this particular user ID, but actually provide demographic features for them. And that's where that was the starting point of this project. Using a service like Instagram, you will have both geolocated pictures in time that indicates a mobility profile for individuals, and each of those pictures you will provide lots of features. So an example would be in this picture that the owner of that account, if you see the rest of the account and this face seems to be the one that is the most prevalent of this account, you can say that this is probably a male Caucasian who likes beer, who engage in alcoholic consumption in social setting. Those are important features because then you can sort of assign them to this particular profile with mobility, and you can collect very, very large examples of mobility in an urban area, and not only have how mobility is present in this area with sort of anonymous mobile data set, which is what people reported before, but now you even have additional features in your mobile data set. So we did that at scale, something that actually anyone can reproduce by looking at geotag pictures on Instagram. We had about 118K users, 35 million geotag pictures. This is actually probably 4 times this number now that we have the crawl working for a longer time. We didn't actually download any of the content of the users because, well, that's going to be a lot to store, and also maybe in a way it's a little sensitive. We only collected the public profile and the metadata of the location associated with them. So the pictures we didn't store. We labeled that in 2 ways. I'm going to go back in the methodology part of this talk to describe it. So basically, using the profile, you could either ask someone from a Mechanical Turk crowdsourcing, or use an algorithm to label this profile from a particular group demographic you want to study. So I'm just going to show you first the results and then discuss a little bit the way the method works. So if you want to reproduce or improve it, you can. So the first result that was important was that we learned that it's possible to reproduce some of the trend, at least at county level in a city like New York, in terms of racial composition using our method. So what we have here on the left is the actual census composition of the 4 most popular US census ethnicity: Hispanic, Caucasian, Afro-American, and others, which include a particular Asian. So on the left, you have what the census, who was the latest census said for that particular county, the county of New York being Manhattan, the county of Kings being Brooklyn, etc. And on the right, you have what our analysis of Instagram, without spending any other money than a server and labeling it through paying a few users to label the crowd online, we're able to deduce a composition for that particular county. And we associate a person with a county by looking at what is the county in which they have the largest number of pictures, which is their home county in a way. So if someone lives in Manhattan but spends all their Instagram life in the Queens taking pictures of something, they would be actually on the Queens. So there are a lot of noises in here that is, part of the process. There's probably a lot of bias as well, in terms of age and population that use Instagram and others. But what's interesting is that you can still see a lot of the patterns that you observe in census just through social media. So for instance, the composition of the Queens being much more diverse than Manhattan, the composition of Brooklyn or the Bronx being particularly different. So that's sort of, interesting because using things that are much less costly and slow than a very large-scale survey, you can actually, or another tool that is the call detail records, which is how mobile companies actually store information about their mobility. You can actually reproduce these trends for very, very cheap solution that is crawling the web and looking at service like Instagram. Not putting that on this slide, but we were able to reproduce things like average distance travel by a typical person in Los Angeles or in New York using their Instagram picture. We could see, what is the daily average trip size and compare it to what was previously reported from mobile companies that use the full sort of data set of call in a city, which is of course much more expensive and difficult to maintain and have. And we were able to reproduce the same trend between various cities. Including weekly maximum distance, median distance traveled during a day, average distance traveled from home from a particular, particular individuals in the data sets. So first thing that is interesting, we can get in a much cheaper way information. Maybe we can get information about places where we have no information as well, which is important. A second thing that is was a result of our study is you can actually enrich your understanding of what's actually happening in this population using social media. So here's an example. This is the CCDF. So for every distance here in log scale, you have the percentage of trips that were made in our data set. So a trip would be you take a picture from Instagram and then the next picture is at a particular distance. And this is the distribution of a distance in a CCDF, but divided among different ethnicity. And the ethnicity were assigned just because looking at the pictures, you could assign this profile to a particular ethnicity. And we found a significant difference between what Caucasian and other will travel compared to Afro-American and Hispanics. And typically, we found the largest sort of gap between those were related to the typical distance you will travel during, let's say, a weekend trip or a trip to another state in the US, which may relate to difference in income or lifestyle or others. We found also a similar interest for how activity at night, like distance travel at night, vary between genders. So it unsurprisingly, female users of Instagram were less likely to make various pictures at a large distance at night than male users, probably because a city at night is less secure and safe, and there's a reason for that. And we found also this sort of interesting pattern that would be this is actually not a geographical pattern. This is a temporal activity pattern. Depending on what time of the day you are, between midnight to midnight, you will have various activity on Instagram. And as probably there is a valley and a peak. The valley is typically when everyone sleeps, and then people wake up, they go to work, and then there's a big burst of activity that happens at the end of the afternoon. So it looks like people just post on Instagram, at the end of the afternoon. What we found, however, was that when you differentiate the weekends, which is shown here in this dashed line, and the weekdays that were looked in the solid line, if you look without ethnicity, you will find that the weekdays have a particular peak at the end of afternoon. And that seems to make sense. People that actually, each of us have work to do, and before 5 p.m. we are not too likely to post on Instagram, but after 5:30 to 6, maybe we are likely to be in a bar and have a good time and share on Instagram. And one thing that we learned from our data set was that if you divide by actual ethnicity, this seems to be particularly true for minority rather than Caucasian. So if you look at it, if you just look at this particular example, it tells that for a Caucasian, a weekday and a weekend are relatively comparable, but for a person in our study group of minority, there is actually a big difference between weekday and weekends. And again, we didn't have any more data to to validate that, but there could be something here related to the type of activity you're doing. Maybe Caucasian like me, who would go are more to be in jobs where you would probably, I don't know, have longer working hours, and you can use social media at other time. Whereas if you're working on, some other type of job where you're required to be just available, maybe you will have a difference in how you use your social media during that time. So all of those point to patterns that were never observed before because there were no actual demographic features in previous activity, either mobile or temporal online. Another thing we looked at was how is segregation present between cities. It's sort of a very important topic, I know, for lots of sociologists. What we looked at is this particular measure of what is called interaction segregation. I'm probably speaking to things you already know, but this is basically how people in different groups meet and interact. So if you look at, for instance, residents, if you have pure segregation, and you have just 100% of a group in one and 100% in another, the interaction is 0. Now, if you have 20-80 and 80-20, there is a little bit of interaction because you can meet people inside your residential area. And they were studied typically using home location zip codes that were shown online. So this is an example of a previous study that was done to show the segregation of various counties in New York. What we did using a similar metric, using Instagram, was to look not only at the interaction segregation at residence level, as it was sort of studied before in residential survey, or even some that were inferred from residential, as this previous plot were, but we could look directly at the segregation of actual interaction online. Do you make a picture on Instagram in a place where only people of your assigned group would do, or do you actually go to places that are more diverse, which would sort of reduce the segregation, at least according to this metric? What we found is that if you look public social media and a particular study group, certainly have lots of various bias in it, but there were more interaction in terms of social group interacting with each other. And the typical reason was that if you assign everyone residence, they tend to be more segregated than the place you actually visit in a city. And maybe many people live in the Bronx, but actually a lot of them have job or weekend trips to Manhattan and mixed more than the actual just picture you have from a residence. Again, something you wouldn't be able to tell without having access to this sort of enriched data sets. And the last thing that relates a little bit to what was my motivation at the beginning of the talk is that, remember, we are very interested in understanding question like, can someone use X of my information to, for instance, discriminate against me based on race? So one question would be, what is the discriminative power of location data to assign, let's say, gender or race to your profile, even if you just share anonymously a few coarse-grained location, like you actually are doing right now with tons of apps. And this is basically the accuracy that you obtain for information at various granularity and precision. And here, actually, for the first time, I'm sure that you understand the x-axis of this plot. Every time I show this plot, it's for computer scientists who have no idea what are these various levels, but I'm sure demographers know. So here you have the block group, which is the sort of smallest unit you have in the US Census, the tract, which is sort of the one that is immediately above, the zip code. Actually, it's a strange one because it doesn't really relate to the census, but it's sort of, the one that is here. There's two of them. Then you have the neighborhood NTAs and the PUMA, which is roughly a big neighborhood. You have 25 of them in New York. Then you have the borough or county, which is the same for New York. And then you have the state. So if I only know a few of your location at state level, well, obviously the accuracy is not going to be that good, especially for people living in New York. Everyone is going to be in New York. A few have a few Instagram pictures out of various other states, but you can't really just have more than a random guess. And this is basically our baseline accuracy. So using Instagram data doesn't give you any more discriminative power. On the other hand, as you start to increase the granularity and to have more accurate geolocation of the users that are disclosed, for instance, at the level of county, PUMA, or neighborhood, or zip code, then you start quickly to reach a high precision, which is actually sort of plateauing at the zip code level. So it means that, if you're worried about sharing your location with GPS because it's exactly a meter and you imagine people can know in which office you live, okay, that's a concern. But if the only thing you care about is they can learn things about you, well, you would have to lie, but not lie just by, a kilometer. You will have to lie by, I don't know, half of the city or something like that to really confuse them, or maybe do something else. But it's not going to be by just removing the precision of your location from a meter to, I don't know, things like 200 meters, things, for instance, that Airbnb is doing with your listings. This is not going to be enough to remove discriminative power. And there's a couple of things you can do with that. I can go in more detail, but perhaps the most interesting is you could use that to actually empower users to know about their data. We build an auditing tool where any of you can send, manual inputs or connect one of their social media account that contains mobile information. And this tool will basically give you that prediction, telling, well, based on what you share online, we predict you are, and that was, in my example, we predict you are white. And that's because you made a certain number of Foursquare check-ins, Twitter with geolocation, and other information you post online that indicates that you visit census tracts that are basically primarily used by Caucasians. And that is sort of an indication that we would classify you this way. And it's important because now I actually know what my data is telling me about me beyond the actual pure raw information that is in the database. And I think we need way more tools like that that are probably going to be needed to be refined a lot according to the various bias they have and different population limitation we have in order to understand that problem and really empower users or anyone who wants to study disparate impact online. This is the URL of the tool if you're interested to use it. I think I have 5 more minutes. Great, okay. So let's discuss a little bit about the method. You need various generation tool. I'm going to describe a little bit the previous, and everything I showed you so far was using a crowdsourcing tool. This is actually, I have a better slide for that. So basically, you can have 3 methods to assign labels, like demographic labels to the mobility traces you have using pictures in the case of Instagram. One of them is just to look at it yourself, or find undergrad to do it, which is what we do in academia. It's expensive. Those guys, cost a lot. And also the speed, well, not bad, but it's as big as you can have undergrad in any great university, and the accuracy is going to be pretty high. Those guys know how to do a good job, especially if you use multiple of them and you look at when they agree, and then you would have a pretty high accuracy we found. That's usually how we use our actual ground truth benchmark. There's no actual ground truth anywhere about ethnic segregation, but the best according to what a US census and people that would really do a good job would do. Then the next thing you can do is using sort of face recognition, which would be basically a way to say, actually, I'm going to look at the content itself, look at the pictures of them, and then you have basically 2 ways to do it. Either you use Mechanical Turk or another crowdsourcing, where you show the pictures and you ask someone online who you don't really know about to label it as, is it a male, female, is it a person that has a family? Because if you look at the whole profile, you can actually tell a lot about that user lifestyle, and of course has them to indicate race and others. That could be sort of free or cheap. It depends on how you pay them. It depends how fast you want the result. It depends how accurate you want the result. You can basically make it, and the accuracy is moderate. There's a sort of a trade-off. Then the last one that would be amazing would be actually just using the metadata of the census. I'm going to go back there. Just using the location of the metadata you have in your mobility, without any pictures. You don't even look at the pictures. You just look at the location, and you train the classifier before on location to assign demographics, and then you can do it at scale instantly because you just need to apply this classifier to the mobility location that you obtain. And for that, you will use typically information from the census that indicates the composition of various neighborhoods. This is free. I mean, assuming you're using public information and really fast algorithm, and the accuracy is going to be probably low. So that's the kind of things we wanted to compare. And we wanted also not only to understand their pure accuracy, but also the relative type of error that they are making. So what we wanted to do, in the second generation was to try to use computer vision, which is going to be this middle ground here, that is using face recognition software, in addition to crowdsourcing to just sort of scale this a little bit. And what we found is a couple of things. So the first thing is that there are good examples. For instance, gender. If you want to have on Instagram a very accurate gender label on your user and sort of understand different behaviors across your population, you're going to have an accuracy of 85%, which is pretty good for anything automated, especially because those data sets are noisy. You have people who have only pictures of landscape, or things like that. So this is really hard to beat. This is typically a conservative prediction, which means that when the algorithm that we built, which is a very simple one, which I can give in more detail, when it predicts that it is 60% accurate, it is actually 80% accurate. So it's always conservative. It tells you, I'm not too confident, but actually it should be more confident than that. So it's pretty, good thing to have. If you look at the actual true positive rate to false positive rate, so this is how much of the actual data set do you recover when you use this algorithm, and this is how much, additional error do you add because you just want to recover more of it. So you can get to, about this thing, which is, about 10% error rate, where you have, about 90% of your data sets that are given. So this is a point where, you have 85% accuracy with a very low set of error. So that's nice. The bad part is it doesn't always work. So an example is if you want to show a race, you want just apply to the same face plus algorithm that is online using the data we have on Instagram that we crawled, and just running it on it, you basically have an accuracy of 82%, which doesn't sound too bad, except that you find a few bad news. The first thing is that the confidence is way overstated. So for instance, it says that I'm 50% confident about that user, and it's actually about 10% accurate. So that's really a bad sign that the algorithm is going to fool you in many cases. And there is way worse than that, which is your error is actually explained by a complete disparity between different groups. What you have here is that essentially you're going to predict most minority to be assigned a white label in this particular algorithmic techniques. And the consequence of that is that you will have a ton of minority being assigned to white. So essentially, white will always be assigned white. You will never be wrong with that because you tend to overrepresent them. But minority will be completely underrepresented in your sample. So here you have, for the number of face that the various quantile of, from a small number of data to a lot of data, for where you classify the users. This is the error rate, how bad you misclassify them when you use this algorithm. In blue you have how much you misclassify Caucasian people, and in red you have how much you classify anyone else. And you can see that not only is it way different, but you also have this sort of strange thing that as people have more and more faces, which means people here are in the fourth quintile, so they are almost the top of the people in terms of the number of pictures they post online, the number of faces that you obtain in them. You have a lot of data about those people. You should be pretty accurate, but you actually end up making a very bad choice. And this comes from the fact that you include faces from lots of people that they have. There's a sort of minority effect, so you have more of the majority of the picture of people with lots of picture, and that caused the algorithm to be wrongly underrepresenting them. So you really need to be careful about any of these bias you obtain in this study. And what we found is essentially that if you were applying this algorithm blindly and say, you know what, I have 82%, it's not bad, I can use a study for that, you will completely underrepresent minority in your data set. So you might be making conclusions that are completely wrong and apply only to a very small fraction of people. So it's very hard, and you need to find neutral algorithm. I'm going to give you an example, which is a very simple trick you can apply to do that, which is called using balance error rate. So when you have these two error rates that were very ugly, one that is not bad and one that is low, it's because the algorithm is sort of maximizing the error rate, but there are not too many of these minorities compared to the large majority group. So it's not too bad for the algorithm to have error rate for those. It turns out to be a good deal for the algorithm to minimize the overall error rate. So one thing you can do is just say, I want the error rate average over various classes. I want this to be minimum. That would be using a balance error rate in your algorithm. And when you use that, when you optimize for this metric, so this is what happened when you use the absolute error rate. This is what happened when you use the balance error rate. And here you have exactly the same plot where if you look at the number of location used, the number of face or the number of location, this is the accuracy you will obtain overall in the two classes, the minority and the white. And you find here that you can have your algorithm would actually be over precise for minority in this case, because in a way now you are boosting the error rate of minority, because although there is less of them, you are going to account for way more of an error whenever you make any of them, because you want to balance the error across categories. So that's the kind of things that are very important whenever you use automation in analyzing some of this social media. I hope I'm still on time. This is just, a couple of points for discussion. We probably need to use social media for demographic research. I'm sure I'm sure I'm preaching to the choir here, but it's really important because we have to engage with this problem of big data disparate impact today. And computer scientists are just lacking the tool and the understanding of that. And we also need to be very careful whenever we use automation and tools. You know, the fact that it's machine learning and has been published somewhere and is very prestigious or whatever doesn't mean that it doesn't have an inherent bias like the one I showed you. And that's just one example of, you know, many of them. So thank you so much, and I'm looking forward to answering your questions in French or English.
Thank you, Augustin. That was a very fascinating presentation. Jean, I see that you are standing now. Do you want to take care of the Q&A period now with the mic?
Sure. Why don't we start with the room?
Any questions? Des questions, commentaires? Quelqu'un qui veut briser la glace?
Oui.
J'ai une question. Nous nous intéressons. Okay. Nous nous intéressons très souvent au réseau, la question qui s'associe avec qui.
Ah, oui.
Et est-ce que c'est possible d'utiliser cette technologie de reconnaissance des personnes dans les photos pour reconnaître avec qui ils socialisent le plus souvent?
Ça,
les personnes de même âge, du même sexe,
c'est une anticipation d'un travail qu'on cherche à faire maintenant. Absolument. On peut tout à fait connaître les liens entre les profils pour plusieurs raisons. Déjà, on peut regarder les commentaires qui sont aussi des métadatas qui permettent de savoir qui commente sur quel profil. Donc, on peut associer des profils qui se commentent. C'est d'ailleurs comme ça qu'on a trouvé les profils. C'est en regardant qui commente et en poursuivant, parcourant l'arbre des commentaires. La deuxième chose qu'on peut faire, c'est regarder dans les photos si on reconnaît les visages de la même personne sur plusieurs comptes. Et on peut dire, ah, il semble que cette personne, son visage est en fait sur plusieurs comptes à la fois. Cette deuxième chose, c'est beaucoup plus intrusif parce que on n'utilise pas explicitement que la personne a fait un commentaire. On la reconnaît ou on le reconnaît sur un autre profil. On l'a pas fait pour deux raisons. Bon, il y a un peu un problème quand même éthique. On pense que ça va un peu loin pour utiliser des données publiques de cette façon-là. Le deuxième chose, c'est que les algorithmes de computer vision qui font ça sont en fait assez mauvais aujourd'hui. Pour reconnaître la même personne quand il faut regarder un très très grand nombre de visages. Ça marche sur votre ordinateur portable. Si vous avez une collection de photos, vous avez sans doute l'option, vous voyez, que vous pouvez classifier, mais c'est parce qu'il y a 20 ou 30 ou 40 personnes qui sont importantes dans votre collection. Quand on regarde là et qu'on a 10 000 personnes qui sont importantes, l'algorithme ne va complètement pas les retrouver. Ça suffit pas. Il faudrait des photos très précises, il faudrait des photos de plus grande définition. Donc on ne peut pas aujourd'hui faire ça automatiquement. Mais on peut le faire avec Amazon Mechanical Turk, par exemple. On pourrait dire, est-ce que cette personne est la même que d'autres? Et on peut aussi utiliser les métadonnées pour faire ça. C'est pas quelque chose qu'on a fait, mais on aimerait beaucoup maintenant utiliser ça pour comprendre est-ce que les groupes interagissent plus? Par exemple, est-ce que une certaine démographie disons par exemple, est-ce que les Caucasians font plus de commentaires sur les comptes des Caucasians qu'en général? Est-ce qu'il y a une vraie mixité online ou est-ce qu'il y a une ségrégation des comptes? Et aussi regarder au niveau des âges ou ce genre de choses. C'est tout à fait, oui, c'est une très bonne suggestion.
I don't know if I should speak in English or French. The people
let's alternate.
Just a couple of points. I think demography can contribute in another way, which is analysis of populations of social media users.
Yes.
You can analyze kind of births and deaths and migrations, where people are, and the age structure that you can more or less estimate the different aspects of the structure of populations, social media users, of other types of big data. And I don't know if that's been done very much, but I think the demographic toolkit can be modified to be of real value for this sort of thing.
That's true.
One point.
Yeah.
The other point is, well, two other points. I think social media data and big data is very useful for studying migration and mobility. Which traditional demographic data is relatively bad at doing. You collect if somebody has died or born, but you don't generally collect if they've moved information. And this can provide very interesting information. I think where it misses, social media and big data is very good at kind of finding intriguing patterns, but it's much less good, I think, probably at kind of behavioral analysis, not just what we see, but what determines what.
Oh, yes.
A lot of times you need other variables that don't exist on the social media and that are extremely difficult to impute.
Yes.
And to get that, you're talking about linking. And linking, you're talking about real problems of confidentiality and privacy. You
yes.
link Facebook to the census on a name to the person.
Right.
And then you start being able to really do an awful lot of things, but you're opening a very big black box, not black box, Pandora's box.
Yes.
Problems.
It's also a black box, yeah. Well, actually, that's a lot of great comments about the toolkit. Absolutely, and I think I've seen very little, thorough analysis of the population of social media. Population being always a ill-defined term because you could have an account not being active. So how do you account for that as well? And I think this was a fascinating, and we need more. And so fascinating topic. I'm sure we would need more of that. I've seen a couple of papers that are on births and deaths in terms of activity of social media, but they are all very, as you say, not educated by years of study of demographic research. So we need to do that. About the black box and the Pandora's box, I agree with you, but I have a little bit of a contrarian argument, which is this is happening. I didn't actually put the slide here, but there is actually a company right now that is linking the various place for the primary of the election in the Republican district to the actual user IDs that were put in some mobile data set of another company. So this linking between domain is happening all the time, and it happens for advertising absolutely, every instant. So I think we should be a little proactive here. We should have tools to understand this linkage, to reveal when it can be done, to empower users to know about it. So I agree with you, we need to be careful, but we also need to be active on it. And as a scientist, we have this sort of good ethic of not doing any harm. That's true, but we should also understand where the danger is. And I'm proposing in my research to do a little bit more. Yes, I want to understand how I can link those accounts. And maybe in a way, I'm going to use an algorithm that someone could use for ill-used. But on the other hand, it's probably better to publish it in the wild for everyone to know, rather than there's a few companies that definitely figure it out and are using it every day. And that's sort of more like my approach to this problem. So I would encourage more research on linking, on using that. And I think there are cases where it could be ethical to do. You could actually find cases where, especially if the information has been public and you can show that the harm is benign, you would be able to keep only the bit of information you need in order to answer a question and not have much added harm to the system. In a way, that's what we did. We used what people donated online to Instagram and left public for everyone, and and thanks to that we could answer things like how male and female differ in how they are in mobility. And our database is anonymous, and we sort of didn't sort of associate that with user in other account. So that's an example where I think we could do that without raising the risk too much. And I think we need to basically answer that. For your second point about explaining and finding a model, I'm a complete proponent of models and simplistic models. Many apostles of big data are like, we don't need any more models anymore because now we have data. I mean, we don't need anything else. We have reality, and everyone who worked with it knows it's a fallacy. Your data are going to contain a lot of noise. It's going to be affected by third and fourth effects and things like that. So at the end, you want to have a simplistic model that from simple codes explain what can happen and see if that model is at play, is creating a cause. And there are lots of examples on social networks, things like the strength of weak ties by granovators, the effect of influence, and all of that, where the models were proposed without much data before. That was pre-network, and we are using those bits of conceptual analysis all the time. So we absolutely should continue to have models, and I wish we have people who believe like that in PC of the conference I go, because we need to continue this fight. I agree with that.
Sarah, est-ce qu'il y a des questions de ton côté?
Oui.
En ligne, personne ne s'est manifesté. Par contre, moi, j'en aurais peut-être une. Est-ce que
D'accord,
je peux? Oui, d'accord. Alors,
avec
c'est en lien
plaisir.
avec la promesse numéro 1 dans votre diapo au tout début, qui semblait suggérer que l'étude des médias sociaux pourrait réduire les coûts liés au recensement.
Ah oui.
Donc, comme vous le savez peut-être, au Canada, au cours des dernières années, la question du recensement a soulevé beaucoup de discussions et d'inquiétudes parce que il a été annulé, le formulaire non obligatoire. Et
Ah
donc,
oui.
ma question en lien avec l'étude des médias sociaux, est-ce qu'on pourrait vraiment faire le travail que vous faites présentement à l'aide des médias sociaux sans le recensement? En ce sens, par exemple, dans cette diapo-là, vous comparez vos résultats à l'aide des données sociales au recensement pour montrer l'exactitude ou la capacité de prédiction, mais sans le recensement, vous ne pourriez pas parler
Ah
des...
oui.
Est-ce qu'on peut se passer du recensement vraiment? C'est l'étalon finalement qui permet de... Donc,
Euh,
voilà. Qu'est-ce
ah
qu'on
bah,
fait
déjà,
sans recensement?
oui, déjà, on peut pas s'en passer pour faire une véritable quantification du bruit et de l'erreur qu'on a dans cette méthode la première fois, ça c'est sûr. Par contre, euh, on peut, on peut, on peut limiter. Par exemple, une chose qu'on peut faire, ce serait si jamais j'avais pas fait le census, je pourrais faire ça pour tous les comtés des États-Unis. Et puis après, je sais que j'ai 25 000 comtés aux États-Unis, j'en prends 1000 et je fais un recensement dans ces 1000-là, je vois l'erreur entre mon estimation et ça m'a déjà divisé par 25 l'effort parce que je sais que je peux extrapoler les autres. C'est pas parfait, mais peut-être il y a un trade-off entre le coût euh, la précision qui rendrait ça possible. Ce serait une façon d'utiliser cet outil sans avoir la ground truth pour absolument tout. D'ailleurs, c'est un peu idiot parce que là, par exemple, si en fait, on n'apprend rien sur cette figure, puisque ça, on sait que c'est très mauvais. C'est ce qu'on a fait, c'est beaucoup de bruit. Ça, c'est très très précis. J'ai pas plus d'informations, sauf pour comprendre ma méthode et peut-être l'extrapoler. Donc, je pense que sans le recensement, ce qu'on peut faire, c'est compléter. Par exemple, s'il y a entre plusieurs années avant d'avoir quelque chose de très précis, je peux aider mon extrapolation avec quelque chose sur des réseaux sociaux. Ou je peux faire cette technique où je sais que je l'ai validé par exemple sur la ville de Pittsburgh et ça a très bien marché à Pittsburgh avec faisant tout un effort de validation. Et après, je vais utiliser le même modèle pour, je sais pas, Seattle parce que c'est deux villes qui sont comparables, ce genre de choses. Ça pourrait être une façon d'éviter d'avoir à payer le coût de validation à chaque fois. Est-ce que ça répond un peu à...
Oui, merci.
Je cherche pas à dire qu'il faut plus faire de recensement. Hein.
Non, je comprends. Je me disais, c'est vraiment fascinant ce que vous êtes capable de faire, mais en même temps, je me disais, même pour poser les questions aux données
Ah oui,
sociales, il faut avoir de l'information, par exemple, je pensais aux transgenres. Avant, on n'en parlait pas. Maintenant, on en parle de plus en plus, mais
oui,
comment les identifier à travers les médias sociaux si on n'a pas déjà au départ un portrait à travers peut-être le recensement ou
oui,
tu
oui.
sais,
Et
les
j'ai jamais vu,
minorités,
j'ai
ça se...
jamais.
Excusez, oui,
Pardon. Je laisse terminer.
c'est beau.
Ah, je voulais juste dire que j'ai jamais vu les données du recensement utilisées autant dans les conférences où je suis, parce que c'est un peu ce que tout le monde a. On sait qu'on a des gros biais dans les populations, qu'on va pas vraiment avoir un résultat qu'on peut complètement être sûr de faire confiance. Et donc, on a toujours besoin de quelque chose. Et en général, les gens vont toujours prendre le census. Et ça fait des limitations parce que finalement, toutes les études ont été faites dans des endroits où il y a le census, parce que c'est facile et qu'on peut le faire. Par exemple, j'ai pas le même plan à Paris. Parce qu'à Paris, il n'y a pas de census par ethnicity qui me permettrait de vérifier ça. Donc je peux appliquer mon social media sur Paris avec la classification des États-Unis et j'aurai un résultat, mais j'ai rien pour le comparer. Donc c'est une limitation. J'ai pas pu faire la vérification sur ce côté-là et sans doute ça marchera pas parce qu'il y aura d'autres facteurs locaux. Donc c'est sûr que le recensement est très très important pour comprendre la validation. Hein, ça c'est sûr, c'est certain.
Merci.
Oui.
Juste un peu pour poursuivre ce point, j'avais lu plusieurs fois que souvent les gens pensent que Big Data arrive, il n'y a plus besoin de recensement. C'est parce que ça valorise le recensement. Ça
Oui.
crée encore plus de valeur pour le recensement. Et ça peut être pour calibrer
Voilà.
Ce que vous avez trouvé, ça peut être pour lier, et le recensement est la seule source de données qui permet de lier peut-être par la suite avec des enquêtes, des données administratives,
Bien sûr.
avec les données, etc.
Et avec
le point tournant qui permet de
oui, le point. interopérabilité. Absolument. Et j'ai envie de dire aussi que, par exemple, bon ça, on n'avait pas besoin du recensement, mais pour faire cet outil-là, le dernier, on a utilisé le recensement tout le temps dans les données qu'on utilisait pour la prédiction. C'est-à-dire qu'on a créé notre classifier qui utilisait d'abord une validation par rapport aux réseaux sociaux, sur qu'est-ce qu'on a regardé. Et une fois qu'on a fait ça, on a utilisé les features des zip codes, les features du recensement pour faire ça. Et encore une fois, il y a non seulement un nombre d'articles publiés qui utilisent le recensement pour faire ce genre d'inférence, et le nombre de produits en ligne pour les annonces ou d'autres qui utilisent le recensement pour classifier les utilisateurs. C'est constamment, c'est sûr. Après, il y aura peut-être des gens à Google qui diront le recensement, nous on a 10 fois mieux chez nous avec l'ensemble des données de Google et de Google Maps, et peut-être ils feront ce pitch, c'est possible. Mais bon, c'est une autre technique parce que c'est beaucoup plus propriétaire et tout ça. Et moi j'aime bien l'idée justement qu'on n'est pas que avec une puissance de connaissance qui est privée, typiquement corporatiste et qui a toutes les raisons de ne pas la partager. On a vraiment besoin de grandes bases de données pour comprendre l'impact. Et je pense qu'on aura besoin de plus de recensement maintenant qu'on a de plus en plus de personnalisation.
Ouais. Que je voulais faire juste rapidement, excuse-moi.
Oui.
Big data est beaucoup plus que juste social media data.
Oui.
J'ai vu des projections à toutes petites zones de la population, mais near real time, qui étaient faites par des données de satellite. Une petite zone au Pérou qui était liée à des informations écologiques qui peuvent être liées à la pluviométrie, etc. Et pendant la meilleure chose, c'est de pouvoir calibrer avec le recensement, mais où il n'y avait pas de recensement, il est calibré, je crois, avec machine learning techniques, et il peut envoyer des équipes sur le terrain.
D'accord.
Un peu calibré, et la machine apprend, il regarde l'intensité de la lumière le jour, la nuit, il regarde les ombres, la machine apprend à reconnaître la différence entre un appartement et une école, etc.
Wow,
et ils ont trouvé même des moyens d'un peu d'essayer d'estimer le structure par âge à partir de ces techniques.
D'accord.
C'est des choses qui sont en train de faire.
Wow.
Maintenant, j'ai vu des projections de population par petites zones de la France en été, mais jour par jour, et c'était à partir des données de Samsung, etc.
Wow,
et samedi, soudainement, Paris devient tout petit et la côte devient très grande. Les gens migrent leur cellulaire à migrer, et c'était calibré sur le recensement.
D'accord.
Une question, c'est un peu, est-ce qu'il faut toujours calibrer? Si on regarde l'Afrique, je crois que le meilleur recensement, c'est l'Afrique du Sud, et ils ont une 15% de la population n'était pas énumérée, selon le Post-Enumeration Survey. Et le recensement n'est pas parfait. Dans d'autres pays, il est possible que des données de satellites non calibrées par le recensement soient plus précis que le recensement.
Wow.
Mais il y a toujours des questions, les deux peuvent être comparés et utiliser l'un pour calibrer un peu l'autre. Je me rappelle, satellite, il y avait, je crois que c'était une petite ville au Nigeria qui n'était jamais recensée, ce n'était pas sur la carte.
Ah oui, d'accord.
Le satellite l'a trouvé, le satellite a estimé un peu la population. Donc les deux peuvent, c'est pas un calibre l'autre, mais les deux peuvent être utilisés pour le contrôle de qualité.
Et sans doute, déjà en machine learning, feront le point que, en fait, avec les deux, on va les compléter, on va combiner, on va gagner encore plus. Donc, je pense qu'il faut peut-être ma promesse numéro 1 qui était on peut remplacer ou retrouver, c'était plus pour montrer que c'était intéressant de retrouver ça, mais je pense que dans la réalité, ce sera beaucoup plus complémentaire. Ça, c'est sûr.
Mon commentaire va dans le même sens que celui de Tom. C'est que il y a également d'autres sources de données qu'on exploite, mais vraiment très peu ici au Québec et au Canada. Et ce sont les données administratives. Et ces données-là recèlent un potentiel analytique et une précision beaucoup plus grande que
donc ce serait par exemple les taxes ou les...
Bon, par exemple, on a le fichier des personnes assurées de l'assurance maladie ici au Québec.
Okay.
C'est un fichier universel pour analyser la mobilité. C'est une source de données extrêmement précieuse et fiable. Et donc, ça, c'est toute une problématique d'essayer de tirer profit de ces données-là à des fins de recherche. Et en plus, si on peut commencer à les apparier ensemble, avec le recensement, tout ça, ben, là, on peut vraiment avoir des instruments extrêmement puissants et qui posent, par contre, des questions, des enjeux qui soulèvent des enjeux très importants du point de vue de la protection des renseignements personnels et du respect de la confidentialité.
Donc, il faudra rajouter des circuits. Remarque qu'il y en a déjà un avec tout le reste. Mais là, j'ai mis que des apps. Il faudrait que je rajoute des satellites, des administrations.
Et sur ça, ben, je vais en profiter pour faire une petite annonce très opportuniste.
D'accord.
Pour dire qu'au Québec, la situation, en tout cas, est pire qu'ailleurs au Canada et dans plusieurs pays européens. En ce qui concerne la possibilité d'accéder à ce type de données-là à des fins de recherche. Et donc, le 30 novembre prochain, on organise une demi-journée de débat sur le thème faciliter l'accès aux données du Québec, comment et à quelle fin. Donc, je vous invite tous à consulter notre site web et si vous voulez, disons, prolonger les débats soulevés par cette présentation extrêmement intéressante.
Mais je pense qu'un point qui va sans doute être lié à ça, c'est qu'il y a un peu cette idée que bon, l'administration, elle me rend un service, elle me fait une assurance maladie et c'est tout. Et je veux pas que mes données soient utilisées pour quoi que ce soit d'autre. C'est un peu le mode d'esprit, j'y pense, qui bloque ce genre de choses. Et c'est un peu la façon dont on avait avant. Ah bah mon provider de mobile, je le paye, il me donne son antenne. J'ai pas envie qu'il utilise mes données pour autre chose. Mais ça commence à s'arrêter toutes ces choses puisque maintenant il y a un tel échange de données. La question qu'on peut se poser dans ces cas-là, c'est comment on régule. Mais je pense que derrière la régulation, il faut aussi se dire quels sont les enjeux et pourquoi peuvent utiliser les données. Par exemple, si on est très 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 strict sur ce qu'une administration publique peut faire, ce sera typiquement le cas aux États-Unis où il y a un grand méfiance pour n'importe quoi qui est organisé par l'État à grande échelle. Le danger qu'il y a, c'est qu'il va y avoir tous les intérêts privés qui eux, vont continuer à faire ce genre de recherche c'est toujours le Big Data Disparate Impact, c'est un très bon outil pour augmenter le profit. Je veux dire, être complètement discriminatif sur plein de conditions, ça va dans le sens, dans certains cas, de maximiser le profit. Donc on peut se poser la question comment faire un peu une sorte de contre-pouvoir, de réaction à ce genre de choses. Et c'est là où les données publiques, surtout régulées, accessibles à des chercheurs qui peuvent montrer les défauts et dénoncer les abus ou ce genre de choses. Et c'est une problématique très importante. Et peut-être les citoyens comprendront un peu plus l'importance ou les régulateurs si on explique qu'on a besoin de ces données pour qu'elles soient utilisées à d'autres fins que la maximation de profit, par exemple. Donc, je pense qu'on peut commenter ce débat là-dessus. On organise à Columbia une conférence qui est un peu sur ces sujets-là. Donc, on verra comment le débat évolue. Merci. Ah oui, bien sûr.
Pour continuer exactement sur ce sujet-là, dans les domaines d'apprentissage des langues naturelles et du machine learning, des entreprises comme Google et Facebook commencent à envahir le monde académique avec des publications qui ne peuvent pas être reproduites, comme vous avez dit au début. Est-ce que vous pensez que ça peut être un danger dans ce domaine-là aussi, que par exemple Google décide d'envahir
C'est un énorme problème. Ça pose beaucoup de questions. Moi, j'ai au moins quelques points que je pense qu'on peut continuer avec ça. En gros, dans les comités de programme d'une grande conférence, on a toujours ce débat à savoir, bon, c'est un résultat très intéressant, mais il n'est pas reproductible. Qu'est-ce qu'on fait? C'est Facebook ou Google qui le propose. On peut faire confiance à l'honnêteté des chercheurs. En général, d'ailleurs, on n'a pas de raison de le douter, mais en même temps, c'est sûr que le processus général est malsain. Les deux choses qu'on peut faire, il y a un peu il y a les avocats et il y a les gens très stricts qui disent non, ça doit être reproducible, il faut que quelqu'un d'autre puisse le reproduire, sinon c'est pas de la science, c'est pas validé externellement, on peut rien dire, ce genre de choses. Bon, c'est une position très stricte. Il y a des gens qui disent bon, de toute façon, on est là pour progresser, on veut comprendre, et c'est un fait intéressant qu'on veut reporter, mais il n'a pas été validé externellement encore. Et c'est un peu comme si on disait c'est une sorte de early disclosure ou quelque chose que, ok, il y a un rapport qu'on pense être scientifique puisque il y a la réputation des auteurs en tout cas qui est en jeu, qui montre telle chose, mais tant qu'il n'y a pas eu une reproduction externe, on ne peut pas savoir. Mais on va quand même le publier en sachant ça. Moi, je suis pas dans un camp ou l'autre. La seule chose que je veux dire, c'est que ce qui est très 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 important dans tous les cas, c'est que les comités de programme acceptent un article qui reproduit ça sous des formes ouvertes. Et c'est pas le cas. C'est-à-dire qu'aujourd'hui, si Facebook fait une annonce sur, je sais pas, un sujet qui m'intéresse, un sujet que j'ai publié, et il montre un nouveau résultat, si moi je le montre 2 mois après avec une technologie reproductible, et sans doute le résultat sera moins bon, j'ai moins de données, ce genre de choses, bah, la conférence va me dire, bah, on l'a déjà vu, c'est pas nouveau. Et bah, ça, c'est un vrai problème. Parce que ça, si on ne permet pas à des chercheurs après de le reproduire, donc là, je pense qu'il faut que les conférences prennent simplement un parti et disent il va y avoir 2 types d'articles, ceux qu'on accepte, mais on sait qu'ils sont un peu avec un warning qui est bon, bah ça n'a pas été reproduit à extérieur. Donc on vous l'annonce parce qu'on veut pas, on veut continuer le progrès, mais on veut pas empêcher la publication future d'articles sur ce sujet qui montrent le même résultat. Ça, je pense que c'est important. Et puis, la deuxième chose, c'est de promouvoir le plus possible qu'il y ait des résultats reproductibles, quoi. Donc, je pense que on est dans un moment un peu difficile parce que il faut toujours, je dois dire, quand on travaille dans ce sujet, on a ce danger d'être scooped par je ne sais pas quel intérêt privé. C'est pas d'ailleurs dans ce domaine-là le pire. Le pire, c'est dans la génomique. Il y a cette entreprise basée en Islande qui a une base de données de génomique absolument incroyable, qui est, je sais pas, 100 fois plus que n'importe quoi qui est public et qui publie dans Nature chaque mois des articles là-dessus. J'ai un professeur du computer science qui m'en a parlé. C'est un énorme problème parce que ça bloque complètement la recherche de n'importe qui d'autre parce que c'est complètement pas à égalité en termes de compétition. Et je pense que j'ai pas envie d'arrêter ces entreprises de publier parce que je préfère avoir des entreprises qui publient et qui partagent, qui viennent aux conférences, qui partagent avec nous. Je pense que ce serait idiot que ce soit séparé comme ça a été le cas dans certains domaines. Et ça a été très mauvais. Ça a simplement fait que les deux se sont séparés, que maintenant on a des algorithmes par exemple, les algorithmes de classification de résultats de moteurs de recherche. La communauté de recherche qui publie des articles aujourd'hui est 15 ans en retard sur ce qui est fait à l'intérieur de Google, parce que Google l'a traité comme une sorte de chose privée qu'il ne voulait pas partager. Et donc maintenant, en fait, on peut apprendre à l'université ce qu'on faisait il y a 15 ans, et puis après on peut avoir un post à Google et fast forward 15 ans. Bon, c'est pas très intéressant comme idée. Donc je pense qu'il faut continuer à dialoguer, mais il faut aussi permettre que des études reproductibles soient suivies des résultats qui ont été publiés. Ça, c'est pas le cas aujourd'hui. Donc on peut quand même le promouvoir, j'espère. Peut-être pas terminé. Merci, excellent point.
Donc, Sarah,
Jean? Oui, j'allais te demander, j'ai pas reçu de questions et personne n'a levé la main, mais j'essaierai peut-être d'ouvrir les micros pour les gens qui sont en ligne encore plus tôt. Alors, si tu veux bien me donner un instant, je vais leur laisser la chance de se manifester. Hello, webinar participants. I've opened your mics. I'm trying to. Philip, can you help me? Okay, I'm opening the mics now. To ask a question, please go ahead if you have a mic, of course. Hello, anyone? So, je pense que personne ne se manifeste. So that will be it for us, I guess. Alors,
Merci.
Jean, pourquoi ne s'est manifesté?
OK. Alors, merci beaucoup, Augustin. C'était très intéressant. Mais à midi, nous avons un autre